Good afternoon. This is machine learning assignment one, and I'll just briefly go over the code, explain some different things that I've done here, and explain the reason why those things are being done. So I'm currently on Google Colab, and just in general, the gist of this assignment is that we will be training a machine learning model to predict the price of a house based on some features that we get from this data set. And so just in general, here we're loading. I'll just run all of this while I'm discussing. So here we load the data set, and then here we can see that the first six samples of the data, and here we can see some information about it, like the different data types and the different features that we have available. And yeah, so this part mainly just does all that kind of stuff. So in the describe function is giving us the main statistics. And then here we're doing some exploratory data analysis where we are seeing the distributions of the data that we have. And you can see that we have a lot of like right skewed data here. So like total rooms, total bedrooms. Uh, so that is something that we can keep in mind when we're actually training our model. And now here we're doing our train test split. So basically what happens is that when you're training a machine learning model, you do not want your test set to be leaked during training. And so you would split that early and then you just put it aside while you do everything else. And then once at the very end, you use your test set to evaluate your train model on basically unseen data. So that's what we do here. We do an 80-20 split, and now we've separated it. And yeah, so uh, that was done randomly and manually. So here I wrote my own split train test function, but then here you can also use the one that comes from sklearn itself. And the next thing we do here is that there's a feature called income, a median income, and that is actually numerical. But what if we want to make it categorical? And that's what we're doing here. We're splitting it into a certain like threshold of bins, so 0 to 1.5 and so on. And then after that, we do stratified sampling. And the reason we do stratified sampling is to make sure that we have a we have a proper distribution of that original data when you do a train and test split, so that you make sure that the train set accurately depicts what is actually the whole distribution. So yeah, that's what we do the stratified splitting here for. And then now we're still doing some more exploratory data analysis where we are plotting a few features. We're seeing the correlations between them, and the same, those are all the things that we do here. And we find that a few features are more correlated than with a few others. Like median house value is very correlated, positively correlated with median income. Uh, and when you make distinctions like that, it helps you to know which features are important when training and which are not. And then what happens is once we've found that, we can actually create new features from the existing ones that we have. So that's what we do here. And then we calculate the new correlation values and we see which one or which features we want to use. And so after we've done that, now we're actually doing like data pre-processing. So we're preparing the data. So here we're handling null values using data imputation. And here we're adding, like here we're encoding categorical or here we're encoding text-based features using numerical features. So all these parts are different ways of encoding and different ways of transformation. So all that goes there. And now this is the part that we actually train the model. So the first thing we train is a linear regression model, which is like, in my opinion, the simplest ones out of the rest, just to test uh, how our features relate to the labels. And so right here, after training it, we predict and we see that we have a mean squared error of $68,627. So if the maximum price of the house is $500,000 in our data set, this is quite a bit of an error. I would say like this is a 30% error given here or there. So right now, this model performs decently well, but it is not as good as we want it to be. And so then we try a decision tree regressor, which is another type of machine learning algorithm. And here we actually see that the root mean squared error is 0. And this basically means that it overfit or it learned the training data way too well, that the error is 0. And so this is wrong. So this is something that we will need to fix and we will need to tune. to find a good model that can accurately generalize even data that is unseen. So yeah, that's a quick summary about this assignment, and I learned how to do data analysis using different libraries like matplotlib and seaborn, and I was able to do some data pre-processing. I was able to do some feature selection, and then I was also able to train a model and train actually two models and see the difference between overfitting and a model that is trained well but doesn't have a very good accuracy. So yeah, thank you.